cosmic background radiation was discovered by American physicists Penzias and Wilson using a microwave detector. Such radiation came from all directions in space, not a particular direction. It suggested that we would be at the center of the universe. Physicists also concluded that this would happen if we were in another galaxy. This thought suggests that the Big Bang model, elaborated on the behavior of the cosmic background radiation, obeyed the same principle. In other words, all the matter in the universe would have been concentrated in a single point in space. From there, an immense explosion would have started time. By giving due importance to the observer's point of view, Images of the Universe defends the thesis that the Big Bang would be informative. As radiation reaches us from all directions in space, it is fair to think that we would take the center of observation, regardless of the physical position occupied in space. For example, if you were in the Andromeda galaxy, you would still remain in the present of the universe, and everything around you would be seen as it did in the past. Thus, the informational Big Bang would be in our present, not our past. The space messenger would create a principle of exclusion from access to our future due to the contraction of time in the inflationary phase. In the first phase of the harmonic motion of radiation, you could not remember anything that happened in your future, as there would be no time that could be measured directly in the direction of its arrow. Without time, there is also no movement. We would have to wait for events to communicate their existence to us late, while suggesting that they would present themselves to us instantly. In the Big Bang singularity, time should contract like a negative movement, resulting from the stretching of space. It's just that when you stretch a rubber band, the force points in the opposite direction. That is, time did not exist before the Big Bang, simply because, even if it did exist, it could not be measured. As soon as the specular inversion had taken place, and time began to dilate continuously, the phase of continuous contraction of space would be established. Not coincidentally, it would amount to the second phase of the harmonic motion of radiation. At this exact moment of inversion of the arrow of time, radiation would exclude the direct participation of space in the communication of events to the observer, and placed in the present. How to explain that the matter of all galaxies could have been concentrated at the moment of singularity? Again, the answer would lie in the behavior of the space messenger. Let's analyze what would be the future light cone of the Big Bang event according to the next graph. The radiation would take the form of a two-dimensional blade with just width and length. To be registered, this radiation would need to be condensed in the form of an agglomerate, a cloud of particles. This would add a third dimension to space, which, on the graph, is represented by time. Without time, the cone would have no depth. Thus, similarly to a negative work of cosmic radiation, this first phase would not exist until the exact moment of the Big Bang due to the contraction of time. Space would lose the dimension of depth. For this reason, some physicists often compare the Big Bang with negative motion, a gravitational collapse that would have resulted in the formation of a black hole. This collapse would also have allowed for the time reversal predicted for the post-Big Bang. The space messenger is the only tool that would have the potential to concentrate all the matter in the galaxies in the center, represented by the two-dimensional blade. Without the depth of space, the universe would become static and timeless. Everything would be in the same dimension, called the present, which escapes us at every moment. So the Big Bang shouldn't be in our past, but in the here and now. As an integral part of all this maths, the observer would be in the present, as well as all galaxies. The fundamental difference, which separates us from the stars and makes them expand, would lie behind the insight that would have given rise to the Big Bang theory. It is because the fact that we are endowed with a memory. In principle, only the observer is endowed with the ability to express his point of view. As our subjective assessment would depend on continuous time dilation, since time is what sustains our memory, it would also depend on the second phase of the harmonic motion of radiation. The previously static universe would spread out into space from our position, suggesting that we would be over the center of the universe. In this model, the celestial vault would be like a movie theater screen, on which information would be projected with a delay. If information were reaching us, it would be from the outside of space-time, and not from within. Since for science nothing exists outside here, physicists concluded that light could only be arriving from the sky, above our heads. All galaxies that would have been above the two-dimensional center before the time-arrow reversal would remain above the center, even as they drift away from each other in the post-Big Bang. But, unlike the observer, the stars would have no way of knowing this. Physicists Penzias and Wilson were fortunate to detect the exact moment and exact location in space where time would begin to be counted from the observer. All the tools used to make this measurement could be considered appendages to our memory. Cosmic radiation is not arriving from our past, because the real arrow of time always points from our present to our future. Because of this, time would result from a negative movement associated with the curvature of space. Confusion about the direction of the arrow of time would have been generated by the behavior of the space messenger, cosmic radiation, which does not depend on the direction of its propagation. All the scientific evidence shows that the universe is the same, no matter which direction it is looked at. That is, we would be at the center of observation, but not at the center of the universe. As we would be living in a universe in which time would be continually expanding towards our past, being accompanied by the contraction of space, it can be said that the expansion, pointed out by the cosmic background radiation, is seen outside its own time. The manifestation of the expansionary phase would only be possible if space were contracting in our past. This contraction, which in reality would correspond to that predicted in the second phase of the harmonic motion of light, would be responsible for us being able to watch the cosmic radiation passing through us, placing us virtually at the center of the universe. Paradoxically, the late exposure of space expansion would depend on its own contraction. Meanwhile, the real universe would remain static at its origin.